Hi friends, let us see today Tesla Model 3 electric vehicle and what is its working principle. It has a driving range of 430 kilometers and the type of motor is permanent magnet synchronous motor rated at 211 kilowatt. It reaches 0 to 60 miles per hour within 5.8 seconds and the cost is 60 lakhs Indian rupees. So it uses the principle of scalar control or V by F control. The ratio of V to F is maintained constant. If you call V by F is equal to K, if you increase the voltage, you increase the frequency. If you reduce the voltage, you reduce the frequency. So if V is 400 and frequency is 50 Hertz, the ratio is 8. For a frequency of 10 kilohertz, voltage to be applied is K into F1. 8 into 10, 80 volts. For a frequency of 20 Hertz, the voltage to be applied is 160 volts. This is followed up to 50 Hertz. As frequency is increased, we increase the voltage. And once we reach 400 volts, we clamp the voltage at 400 and increase only the frequency because the machine is designed for 400 volts. This is the concept of V by F control. So you have wide range of speed. By increasing the frequency, wide range of speed can be obtained and high efficiency. So Tesla has changed from induction motor to permanent magnet synchronous motor because PMSM has efficiency of about 90%. So the power is fed from a 3-phase inverter. This 3-phase inverter consists of 3 legs. So it generally the best PWM is space vector PWM. So space vector PWM has 6 active states and 2 null states, and the THD is less than 5%. So here a triangular wave is compared with an M-shaped waveform to generate the pulses. The switching sequence of the inverter 612, 123, 234, 345, 456, 561, and null state is triggering all the upper devices, say 135 or 246. So in null state 0 voltage is applied. If you want to reverse the sequence, after 612 you get 561, then 456 and so on. So in an electric vehicle, if you select the reverse option, the switching pulse sequence is reversed and direction of rotation of the motor gets reversed. So the output voltage of the inverter is like this. So we don't like single big fish, we like fish chops. Similarly, the motor doesn't like continuous square wave, it likes train of pulses. So this is a permanent magnet synchronous motor. You will have magnets in the rotor. In the stator you have 3-phase distributed winding. So it works on the principle of magnetic locking. The rotor gets locked to the field in the stator. So when a 3-phase balanced voltage is applied, a rotating magnetic field is produced and the rotor poles get locked to the rotating magnetic fields and it will be running along with the field. In a successful married life, the husband gets locked to the wife and they run synchronously. So this is construction of PMSM. You have three-phase winding in the stator and permanent magnets in the rotor. The stator of PMSM is similar to stator of alternator or stator of induction motor. The waveforms are sine waves. Your flux is sine wave, unlike PMBLDC. Your EMF is a sine wave, current is sine wave, and hence the harmonics are less. If the harmonics are less, the losses due to harmonic currents are reduced. So there is a problem called instability in PMSM. If you suddenly increase the load on the rotor loses synchronism. The angle between rotor and stator field is load angle. If the load angle is more than 90 degrees, you will have instability. So if you keep scolding your spouse for more than 90 days, you will have unstable life. To avoid this, we use what is called self-control. Separate control or open loop control means simply we give pulses, we don't look at the rotor. But in self-control, we look at the position of the rotor and accordingly we adjust the frequency of the pulses applied to the inverter. So frequency of the inverter is slave to the rotor position. So if delta is increasing, we will reduce the frequency, or if delta is decreasing, we will increase the frequency. So this will maintain stability. This is similar to yourself driving behind a bus. So if you are on the two-wheeler, if you are driving behind the bus, if the bus speed is increasing, then you increase your two-wheeler speed. If the bus speed is reduced, then you also reduce your speed. So if you have self-control and if you are driving behind the bus, assuming that you cannot overtake, then you can maintain stability if the clearance is maintained constant. So we can maintain stability in PMSM if delta is maintained constant. So a dual stator PMSM will have two inverters. This is inverter 1, this is inverter 2, two stator windings. Generally at the time of starting, we use both the inverters, both the stator windings to produce more power. Whenever vehicle is overtaking the other vehicle, then also we use both the inverters so that more power, mechanical power is produced. So thanks for your patience, and I request you to subscribe to my channel Ramareddy Sarthi.